So we're asked to convert, find the polar coordinates of a point with Cartesian coordinates. So we have x and y. We need it as r and theta. So you can find r and theta really quickly with this formula right here. There's formulas to go from polar to Cartesian, and then there's formulas to go from Cartesian to polar. So the two that are going to help us find r and theta are these ones down here. So to do that, r is going to be the square root of x squared. There's x squared plus y squared. And then if we simplify, we're squaring everything, so negative 7 squared makes 49. The square root of 3 squared makes 3. 2 squared makes 4. And we got 7 squared makes 49. 2 squared makes 4. Oops. And so you've got whatever the heck 49 times 3 is. We got 147 plus 49 over 4. Hope it's something nice. Plus 49. Divide that by 4. Oh man, the whole thing is 7, because this is 49 in our calculator. The square root of 49 is 7. So we found r. R is 7. Theta is going to be inverse tangent, or arctangent, of negative 7 over 2. That's our y. And then I'm rewriting it with the division symbol. Divide by negative 7 square root of 3 over 2. And so that's inverse tangent, not tangent in the negative first power. Negative 7 over 2 times 2 over negative 7 square roots of 3. So cross cancel these. Cross cancel these. So we're asked for tangent, inverse tangent I should say, of square root of, sorry, I won't skip that part. 1 over the square root of 3. Which, you could use a calculator there, but to find this, this is like saying tangent of what angle equals 1 over the square root of 3. And that's where you could play around with the special triangles that we have. We know it's got to be the 30-60 one because that's the only special triangle that involves the square root of 3. And so tangent is the opposite over the adjacent. So let's take a guess. Let's guess that theta is 30. If that's true, then 1/2, the opposite, divided by the adjacent should equal 1 over the square root of 3. So let's flip and multiply. And that works out. That's the one. Okay. So 30 degrees is our answer, or in you can convert that to radians, which is pi over 6. Okay. So oh yeah, I think that's what they want. They want it in radians. So our answer here is 7 for r, and then we got pi over 6, which is 30 degrees for radians. Very sorry, I stopped that video short. That's for finding, this is a tangent theta equals a positive 1 over the square root of 3, and I committed a cardinal sin of trigonometry. Remember, tangent is positive here, so we got the positive 1 over square root of 3. All students take calculus. Tangent's positive over here as well. So when considering which one, this is pi over 6 for a reference angle. So this one is, wait, what is that? Pi over 6 plus pi. That's 7 pi over 6. We have two answers, pi over 6 and 7 pi over 6. Which one is right? We'll just go back to the Cartesian coordinates. Negative 7 square root of 3 over 2. So it's negative on the x-axis. And then it's negative 7 over 2 on the y-axis. So it's going to be this one for our terminal point, the 7 pi over 6, because that's the one that brings us into that third quadrant where the Cartesian coordinate lands. So watch out for that. And remember what we learned in trig, and don't do what I did. Don't just stop once you get one answer. Remember, there's two answers to this equation, pi over 6 and 7 pi over 6 when you draw them both out. 7 pi over 6 is our winner because that's that'll give us the angle that lands us in the same spot as that Cartesian coordinate.